every participant. To start with, why predicting crude oil prices is a game changer. Just imagine you are trying to plan your monthly budget with the price of milk, which changes every single day. Now just replace your milk with crude oil, the fuel for your transport, your power generation, all those things, which randomly changes each and every hour, every minute. The whole world feels it. That is why predicting the price is not just important, but also it's a game changing. Hi everyone. To throw a light on this, I am here, Balasubramanian. I am working as a system manager in Indian Institute of Foreign Trade. It's a B school, and I am also working as a research scholar in Annamalai University, and I am doing my PhD in AI and ML. The title of this research paper is Trade Forecasting with AI and ML, integrating ML concept and DL concept along with explainability. Why this research is very important? This research uses AI blending with machine learning and explainability tools to make the crude oil forecasting very accurate as well as very transparent. This is my introduction and motivation to do this research paper. The significance of crude oil price prediction for a global economics, inflation, and markets, as I said in my first slide. Growing interest in AI-driven in economic forecasting. As I am working in a trade institution where the trade forecasting and crude oil pricing and exchange rate, all these are very important. We are also part of Ministry of Industry and Commerce. So this research would be very useful for the policymaker to take the investment decision and risk management in a volatile market. What are the challenges? The primary challenge is the volatile market dynamics make forecasting very difficult. And what is the gap? Especially the traditional models lack in explainability and adaptability. It's a black box like a concept. So that is the gap. The challenge is the volatile market dynamics, which forecasting is very difficult. That research problem, the problem to be addressed. AI models are often, I'm talking about the traditional models, black box, limiting trust. How it is happening, nobody knows. Why it is happening, nobody knows. We know it is happening, we can forecast. So the lack of transparency hinders informed policy and decision making. The primary research questions are, can random forest and LSTM, that is effectively predict crude oil prices? How can shape and line add explainability to your forecasting? This is my problem that I am going to address, and these are the research questions. That research objective, it is very important to identify the best forecasting model. Compare that model with ML versus DL performance. Apply shapely, that is, it's a very popular method model in number theory. Especially economists are vastly using this, and Lime also for transparency. We should not ignore the benchmark concept against that ARIMA model, Prophet model, and transformer model. And last but never the least, our research objective is to confirm the statistical significance of all these results that we are going to, how we are going to add that AML concept, especially ML with the cushion of DL, and adding to the explainability in terms of maintaining the transparency by applying that shape and line. Methodology overview. See, we all would be knowing the random forest method is there, model is there, LSTM model is there, that we can very well predict any trade forecasting, not just crude oil, but also any commodity we can predict using this random forest, which is coming under machine learning, and LSTM, which is coming under deep learning. But research primarily focuses on introducing explainability via shape and line to identify feature impact. What are the drivers? What are the drivers that impacting on the forecasting? What are the features such as the global market and the exchange rates? All these features, how it is impacting the forecasting. And as I said, last but never the least, benchmark against the baseline models like ARIMA, PROPE, and Transform. This is our methodology overview. So we are adding ML with DL and introducing explainability via shape and line and benchmark against the baseline model, ARIMA, PROPE, and Transform. You can ask why we need to use both random forest and LSTM. When random forest is enough for forecasting any commodity rate pricing and all, what is the need of combining these two into one? That is random forest of machine learning and LSTM of deep learning. Why we need to combine these two? See, random forest, as you know, captures complex nonlinear relationships in variables. But LSTM is great for recognizing the time-based pattern in a sequential day. Together, they can both perform and give you the accurate results. So, in terms of for accuracy, we are using both random forest as well as LSTM. In our research objective, we mentioned that both accuracy as well as transparency. So, we need to give the trust to the policy maker why it is happening, how it is happening. So we are using shape and line, that is, those are XIA concept, adding together with this DL and ML. Why benchmark against ARIMA, PROPET, and transformers? These are widely used baseline in type series forecasting, so they provide a solid performance comparison. So you can segregate into three parts. First is to maintain accuracy to give an accurate results. We are combining both random forest as well as LST. The second, to give the transparency, to maintain the transparency, we are using shape as well as line. Of course, to benchmark against the baseline model of time series forecasting like ARIMA, PROTECT, and Transformer, we are comparing those models with our proposed model. Explainability tool. As I said, I'm going to use Shapely additive explanation as well as local interpretable model agnostic. See, as I said, shape is show feature contribution like which driver is impacting on individual prediction. Whereas that line is morely focuses on local interpretability per prediction, individual basis. So both enhance stress by demystifying black box output. That ARIMA and your other models may give you some results, but it's like a black box result. With due respect to those models, those are black box in nature. Black box in the sense we do not know how it is happening, why it is happening. We know that crude prices will be this much in a particular point of time. But to enhance the trust, we are using explainability tools, both shape as well as line. Shape stands for Shapley additive explanation. It is vastly used in the number theory. Line is local interpretable model explanation. As the name suggests, it is more towards local interpretability per prediction. Again, like why ML with DL, why ARIMA with LSTM, here also the same question. Why are shape and line both needed? When one is enough to maintain the trust, to give the transparency, why we are comparing? Shape gives you a global view, which features matters from while line explains the individual predictions. Like this is what this is. This is based on this. So that compare each other to build full transparency. for a certain strike price. Shape rebel it may sudden drop in OPEC supply, Organization of Petroleum Exporting Countries supply. While Line explained that specific month currency depreciation was the main driver. So this is the underlying difference between shape and line. This is why we are using both shape and line combined together, like we use ARIMA as well as LST. See, now we are in a position to compare the traditional model versus AI driven. AI driven is our proposed model. First, to look into the traditional model, uses only past crude oil prices, and more importantly, it works in stable market conditions. Struggle with sudden market shocks like geopolitical events, limited number of factors to be considered. These are the you can say these are the concepts that using traditional model. When you are using the AI-driven model, you can consider multiple factors like supply demand balance, exchange rate, global geopolitical event, all those things, production costs, all those things you can use. And random forest will use to find the hidden pattern across the pattern. LSTM will capture time-based price movement, whereas the shape and line combined together explain the key drivers behind the prediction, whether it's based on the supply or the demand, supply demand balance, exchange rate, any geopolitical events, all those things it will. To give an example, model predicts the traditional model predicts crude oil prices based on historical data, global demand, and supply indicators which has happened in the past. Suppose, say for instance, I am using this traditional model to predict the price for crude oil for the next month. It will give you the output X dollar per barrel, but no explanation on which factor influence this prediction the most. Traders must trust the model without knowing the reasoning behind the. That is the primary issue with the traditional model. As I said, with due respect to the traditional model, this is the primary issue with the traditional model, that traders must trust that model without knowing the reasoning behind the forecast. Whereas, on the other hand, AI-driven model, it will give you the same prediction, the predicted price for the crude oil for the next month or for the next year or for August 2028. It will give you the same output as X dollar per barrel, but it will also give you what are the factors that impacted the most, whether it's a OPEC production cut increased price by A percentage, a strong USD dollar decreased price by L percentage, rising demand in Asia added M percentage, all this. So, in this model, traders can verify, adjust strategies, and test the forecast because the model is very transparent. Because it is giving you all the drivers, all the features through shape and line. We are giving all the drivers and how it is impacting. Like here, I am just an example how the OPEC production cut increase price is impacting, and strong USD decrease price by L percentage, how it is impacting, and rising demand in Asia added M percentage, how it is impacting. So in this model, whereas the traditional model, traders must trust the model without knowing the reasoning. Suppose if the value is predicted as X dollar per barrel for the month of August 2028, the trader must trust the model. Whereas in AI driven, traders can verify, adjust their strategies, whether it is based on OPEC or USD exchange rate value or rising demand, geopolitical events, all these that traders can trust and verify accordingly, adjust their strategies as this model is very transparent in nature. So this is a framework flow. Uh, Actually, I am using data from data.gov. It's a very genuine data and it's openly available. It's an open source. Historical crude oil price and relevant economic indicators I have downloaded and have, of course, by default handling missing values, normalization, and feature engineering, but zero sum and all. I have done that. The second is very important model development. How the model is being developed. Machine learning, I'm using random forest for pattern recognition, deep learning for sequential trend capture, actionable insight for decision makers. Third is integrating explainability by means of shape for global feature importance and line for local instance level explanation. Last but never the least, benchmark comparison. In our research, we are comparing this figure with baseline models like ARIMA, Propate, transformer models, and statistical validation of performance, output and insight, accurate forecast with clear feature. That is, we are the focus is mainly on accuracy, not just accuracy, but also transparency. So accuracy as well as transparency. This is the actual framework. Data collection, pre-processing. The process data will go to the model development, random forest and LS. That prediction will go to the explainability tool, that is shape and line. That explainability results will be compared with benchmark comparison with the baseline models, ARIMA, Propet, and Transformer. That performance validation, forecast and validation, forecast and insight, accurate and transparent we are making. This is our framework. Data collection, through data collection, process data will go through pre-processing to the model development. Their model is random forest and LSTM, that is ML and DL. Then the prediction will go to that predictional model will stop at the prediction. That's it. That prediction, it is giving you some figure, some value that is $X per barrel in the month of August 2028. But that prediction will go to explainability tools in the framework where that shape and line we are giving you why it is happening, how it is happening based on local interpretable as well as global view. Then we need to compare with the baseline model of time series forecasting. So we are benchmarking it with ARIMA and Profit and Transformer. That forecast insights will give you accurate, transparent results. This result accuracy comparison combined random forest and LSM model demonstrated superior accuracy. See, in DL and ML, we are giving you an accurate results. Statistical sets confirm that proposed model outperform ARIMA, Profit, Transformer in predictive performance. Why? Because we are combining both together. Not just random forest, not just LSTM alone, but we are combining both DL and ML through random forest and LSTM. Uh, this is our RSME me comparison for random forest and LSTM. You can see here it is giving you the accurate result in terms of the other baseline models like ARIMA, Prophet, Transformer, all those things. Now, compared for the result explainability, shape highlighted the future most influential the prediction. In our case, it's supply demand indicators, exchange rates. It will give a lead to our next research, which is purely based on exchange rate that I will touch upon in my second last slide. Line provided interpretable local predictions for specific data. As I said, shape is global view, line is local view. Overall explainability, improve transparency and analyze the trust. So trader must be knowing why it is happening, how it is happening, what are the factors, what are the features, what are the drivers that is impacting on the prediction of a particular commodity. In our case, it's crude oil. Sorry. This is the line explanation. Okay, local thing. Suppose here the factors are global demand, USD exchange rate, trade volume, and supply. Features are these four: global demand, USD exchange rate, trade volume, and supply. Predicted value, you can see that minimum and maximum, negative or positive, based on this. Whereas global view, shape, impact on model output, all these together. Global, these are the four primary factors, primary features that is impacting on our prediction. Contribution. What is our contribution? Develop an accurate, interpretable AI forecasting frame for crude oil. Demonstrated how the explainability tool makes model trustworthy and actionable. See, we should not only talk about accurate, we should not only talk about transparent, but we should also talk about how the model is working as an actionable one. Then establish benchmark against the traditional forecasting model with statistical value. Limitation, of course, um, I know what I don't know. Current model may still suffer from non-stationary and data. See, though we have taken the data from data.gov.in, but these data had more noises and more missing values. So through pre-processing and all, it was very difficult for us to do the needful. And that pre-processing also required time to make it as an input to the model. Future research could explore domain-specific feature engineering or real-time explained model. Instead of taking data from some sources, it will take the real-time value and it can work as an app or it can work as a framework. Additional data set could improve generalizability beyond crude oil market. See, not just crude oil, as I said, we can take the data, demand supply data, and we can take Asian demand supply, how the market is. We can take the data. Last but never the least, we can take the exchange rate data also. Primarily US dollar, Japanese, and yen, and UK pound, along with our Indian rupee. Overall takeaways. What is the overall takeaway for this research? Random forest is an obvious choice for structured tabular prediction. LSTM is an ideal method for time series. Okay. Both shape and line enhance model transparency and making AI-driven price prediction more interpretable and explainable. So, for structured data, random forest, RF; for time series forecasting, LSTM; for shape, it's a global value view; line for local view. Combined together, we can make our model more interpretable and explainable. The final words. The hybrid approach, that is random forest, LSTM, shape, line, offers a balanced blend of accuracy and enhance the decision making capabilities for stakeholders, that is policymakers or importers, exporters, traders, through transparent AI. Sets a foundation for trust oriented AI forecasting framework in economics. See, especially in India, AI is in the nascent stage. mostly people won't trust the AI model. So it will, this research paper, we believe that it will set a foundation for trust-oriented AI forecasting framework in. Thanks a lot. Any questions?